The challenge there is that NASA is currently under government shutdown, and so we cannot get any communications from NASA, and that prevents the flow of data that was already obtained.
From nearly 1 million miles away, the James Webb Space Telescope has just confirmed something that sent shockwaves through the global scientific community. The interstellar object known as 3I/Atlas, a traveler from beyond our solar system, is now on a potential collision course with Mars. What began as a faint anomaly in orbital data has turned into the most alarming discovery of the decade. At first, astronomers thought it was a glitch, but every recalculation, every simulation led to the same result. 3I/Atlas is veering off its original path, heading straight toward the red planet at over 130,000 miles per hour. If the impact happens, it would mark the first time in human history that an object from another star system has struck a planet. The implications are staggering. This could unlock secrets about alien materials, life's origins, and even planetary defense itself. But behind the excitement lies a chilling question. What forces could change its course? And what would happen if 3I/Atlas actually collided with Mars? When astronomers first detected 3I/Atlas in early 2025, it seemed like just another cosmic passerby. It came drifting into our solar system from the direction of the Hercules constellation, moving at nearly 134,000 miles per hour. Too fast, they thought, to be captured by any planet's gravity. It was catalogued as the third interstellar object ever recorded, following the mysterious Oumuamua in 2017 and the icy comet 2, I/Borisov, in 2019. Both of those had entered, passed through, and vanished back into the void. So naturally, scientists assumed 3I/Atlas would do the same. But this time, something was off. When the James Webb Space Telescope turned its golden mirrors toward the object, the readings didn't match expectations. Instead of tracing a smooth exit trajectory, 3I/Atlas appeared to be slowing, ever so slightly, then bending its course inward. Over weeks of observation, its orbital curve began to shift, pointing unmistakably toward Mars. It wasn't a calculation error. NASA's Jet Propulsion Laboratory, the European Space Agency, and observatories in Chile all confirmed the same deviation. Whatever force was acting on 3I/Atlas, it wasn't random. That raised the question no one wanted to say out loud. How does something from another star system change direction inside ours? Some astronomers suggested a burst of solar radiation, a coronal mass ejection powerful enough to nudge its path. Others argued it might have passed close to an uncharted fragment of debris, exerting a minor gravitational tug. But even those theories failed to explain the precision of the curve, as if the object had been steered, not deflected. The data showed a trajectory that would take it within a few thousand miles of Mars, possibly closer. Simulations at NASA's Goddard Space Flight Center revealed a window in which a direct impact, while unlikely, was not impossible. It was enough to send alerts rippling through research teams across the world. Telescopes on Earth were reoriented. Space agencies began updating orbital models in real time. In the span of a few days, 3I/Atlas went from a scientific curiosity to a potential planetary event. Its pale blue coma glowed brighter, its tail stretched longer. And for the first time, astronomers could see faint jets of gas venting from beneath its surface, signs of internal activity that shouldn't exist in an interstellar traveler. Whatever this object is, it's no longer just passing through. Something has drawn it into our cosmic neighborhood, and now all eyes are on Mars to see what happens next. The first real shock came not from a photograph, but from the light. As the James Webb Space Telescope studied 3I/Atlas, its instruments picked up wavelengths that made no sense to anyone watching the feed. Every celestial body carries a kind of fingerprint, a chemical signature written in light. And this one didn't match anything known within our solar system. Webb's spectrograph revealed that the halo surrounding 3I/Atlas was saturated with carbon dioxide and microscopic dust, but almost entirely devoid of water. That shouldn't be possible. Every comet ever observed near the Sun releases vapor as its frozen surface melts, creating brilliant streams of ice and gas. Yet 3I/Atlas remained bone dry, its glow faint and cold, as if it came from a region where ice was never meant to exist. Astronomers realized they were staring at a traveler from a place where light is weak, heat is scarce, and the rules of planetary formation may have been different altogether. Further analysis deepened the mystery. Webb detected an abnormally high concentration of carbon isotopes, levels that hinted at something cataclysmic in its past. According to Dr. Avi Loeb at Harvard's Galileo project, the ratio could only be explained if 3I/Atlas had once drifted through the shockwave of a supernova, absorbing the raw debris of a dying star. That would make it not just an interstellar rock, but a fragment of stellar death, matter forged in one of the universe's most violent events. Cross-checks from other observatories only confirmed the anomaly. The Gemini North Telescope in Hawaii picked up faint gamma traces, while the ALMA array in Chile detected low-frequency radiation patterns consistent with aged cosmic dust. Each new observation told the same story. 3I/Atlas carried materials billions of years old, possibly from a system that no longer exists. If that's true, then Mars might soon become the first planet to encounter relic matter from beyond our galaxy. Scientists around the world are calling this the most significant find since Oumuamua. But behind the excitement lies an unsettling thought. If 3I/Atlas is a messenger from a dead star, what exactly is it trying to deliver before it collides with Mars? At first, the trajectory of 3I/Atlas looked ordinary, another deep space traveler cutting through the solar system before fading back into darkness. Early simulations from NASA and ESA both agreed. It would pass harmlessly by, never getting close enough to matter. But within weeks, the numbers began to shift. The latest orbital maps showed a curve forming where none should exist, a gradual bend pulling the object closer to Mars every single day. By late September 2025, the data became impossible to ignore. The James Webb Space Telescope confirmed a projected closest approach of just 29 million kilometers, tighter than any interstellar object has ever come to a planet in recorded history. News outlets around the world gave it a name, the Red Encounter. At first, scientists treated it like a sensational headline, a near miss, not a collision. But then, the updates kept changing. Webb's precision instruments tracked subtle but consistent variations in both velocity and heading. In less than 2 weeks, the object's speed had fluctuated by more than 600 miles per hour, and its path continued to tighten. That level of deviation couldn't be explained by solar wind alone. Some scientists across space agencies call it a living orbit, one that seems to evolve in real time. Magnetic fields, solar radiation, gravitational resonance with Mars itself? None of the usual forces fit the data. What worried researchers most was the timing. The closer 3I/Atlas came to the Sun, the stronger the anomaly grew, as if something inside it was responding to the heat, adjusting its motion in ways no known natural object could. At NASA's Goddard Space Flight Center, teams began running revised impact models. Each new dataset forced them to recalculate again and again. Some simulations predicted a near miss so close that fragments of the object's tail could brush against the Martian atmosphere. Others suggested a shallow impact near the northern hemisphere, enough to scatter debris across hundreds of miles. Every hour, the uncertainty deepened. The usual predictability of orbital mechanics, the foundation of astronomy itself, seemed to crumble in the face of this object's behavior. For now, NASA and ESA continue to urge caution, maintaining that the odds of a direct collision remain statistically low. Still, the data tells a story that's hard to ignore. No natural object should shift its path this drastically, this fast. If 3I/Atlas continues to deviate at its current rate, the line between a near miss and a planetary impact could blur faster than anyone expects. The question haunting every control room is simple and terrifying. What invisible force is steering it toward Mars? If the unimaginable were to happen, if 3I/Atlas actually struck Mars, the results would redefine everything we know about planetary collisions. If a collision were to happen, the force released would be beyond anything humanity has ever witnessed. Scientists estimate that the impact could unleash hundreds of millions of megatons of energy, enough to make the Martian sky burn brighter than the sun for a brief, blinding instant. The planet's thin atmosphere would do little to cushion the blow. A fireball would tear across the surface, lighting up the solar system as the shockwave raced outward into space. Traveling at nearly 134,000 miles per hour, 3I/Atlas would slice through the Martian sky like a spear of light before detonating with enough force to be seen from Earth without a telescope. Scientists estimate that the resulting fireball could glow brighter than Venus, leaving a column of plasma that pierces the upper atmosphere before collapsing in a violent shockwave. The initial impact would carve out a crater up to 30 to 50 kilometers wide, vaporizing everything within seconds and sending molten debris arcing into orbit. The real devastation, however, would come from what follows. Fine dust would billow into the sky, spreading across the planet like a veil. For weeks, sunlight would dim. Temperatures could drop sharply, possibly freezing any shallow water reserves still hidden beneath the surface. To planetary scientists, this would be a once-in-a-lifetime experiment, an opportunity to study a natural terraforming event, one that might briefly warm certain regions even as others plunged into deep cold. But there's another layer of mystery that makes this scenario so extraordinary. Unlike any other known impactor, 3I/Atlas carries chemical material from beyond our solar system. If fragments of it were to survive the collision, they could embed alien isotopes, heavy elements, and organic compounds into Martian soil. As Dr. Alan Stern once said, "Studying interstellar objects is like holding another solar system in our hands, a direct encounter with something that was never meant to belong here." For humanity, it would be both terrifying and transformative. Robotic orbiters like MAVEN and Perseverance could record every second of the event in real time, turning Mars into the stage for the most spectacular explosion ever observed. And while astronomers debate its risks, one fact remains. If 3I/Atlas makes contact, we will become the first civilization to witness an interstellar object collide with a planet. For centuries, humans have looked to the skies searching for signs of other worlds. Now, one of those worlds may be about to collide, literally with ours. All across the solar system, eyes are locked on Mars. It's not just Earth-based telescopes anymore. Orbiting high above the red planet, a silent fleet of machines, Mars Odyssey, MAVEN, the Trace Gas Orbiter, and the Perseverance rover are all standing by, their sensors trained on a single target, 3I/Atlas. For weeks, mission controllers have been reprogramming each spacecraft to capture every possible angle of the encounter. Odyssey, the oldest of them all, has switched part of its infrared instruments toward the upper atmosphere. MAVEN, designed to study Martian air chemistry, is ready to record even the faintest ionization changes that might ripple across the sky if the object brushes past. And on the surface, Perseverance has parked its cameras in a fixed position, waiting for the dark streak that could mark 3I/Atlas's arrival. In orbit, the Trace Gas Orbiter has been assigned the most delicate task of all, tracking any chemical residue if debris from 3I/Atlas enters Mars's thin atmosphere. Engineers at ESA call it chasing the shadow, a race to capture evidence that might last only seconds before vanishing. Every byte of data is being streamed back to Earth, where AI models at NASA's Goddard and ESA's ESOC centers are feeding it into simulations, updating trajectories hour by hour. Even the long-silent InSight lander, which shut down 2 years ago after being buried in dust, is still contributing from beyond its grave. Scientists are using its archived seismic readings to model what kind of shock waves would ripple through Mars's crust if an impact actually occurs. The planet itself has become a giant natural experiment, one where geology, astronomy, and history might collide all at once. Meanwhile, far from the red planet, the James Webb Space Telescope continues to watch from nearly 1 million miles away. Its high-resolution imaging has turned the 3I/Atlas approach into a slow-motion event, capturing faint flashes of sunlight reflecting off the object's rotating surface. Each flicker tells scientists something about its shape, its spin, and maybe even its internal structure. In a way, the entire solar system feels like it's holding its breath. Mars has never been this closely observed, not even during the first rover landings. Billions of miles apart, robotic explorers and human scientists are all staring at the same patch of sky, waiting for history or catastrophe to unfold. And as 3I/Atlas closes in, one thought hangs in the background. Maybe the most important discovery won't come from what it does to Mars, but from what Mars reveals about it. If fragments of 3I/Atlas were to merge with Martian soil, they could carry chemical compounds unlike anything ever found in our solar system. Scientists believe its debris might contain primitive carbon chains, amino acids, or prebiotic molecules, the same ingredients that once gave rise to life on Earth. For astrobiologists, this isn't just an impact to study. It's a natural experiment on a cosmic scale. For decades, researchers have debated a theory called Panspermia, the idea that life can travel between planets, hitchhiking on rocks ejected by impacts and carried across space. Meteorites from Mars have been discovered on Earth before, such as the famous ALH 84001 found in Antarctica, which contained organic molecules once thought to be fossils of Martian microbes. If those fragments could cross the void, then perhaps the same process could work in reverse. Now, with 3I/Atlas possibly heading toward Mars, scientists may get to watch Panspermia in action. The chemistry of the object only strengthens the speculation. Earlier, Webb data showed that 3I/Atlas is unusually rich in complex carbon compounds, structures capable of forming amino acids under the right conditions. These molecules are the building blocks of DNA and proteins, the foundation of all life as we know it. A collision could scatter them across the Martian surface, where they might interact with trace water and minerals already present there. It wouldn't create life instantly, but it could plant the first seeds for something entirely new. Dr. Avi Loeb put it bluntly in a recent statement. Life may not have started on Earth. It may have simply stopped here for a while. His words have reignited old debates within the scientific community. If interstellar material like 3I/Atlas can transfer life's ingredients from one world to another, then every collision, every comet, and every drifting fragment could be part of a much larger biological network linking the stars. To some, that idea is thrilling. To others, it's deeply unsettling, because if life can spread so easily, it raises another question. Did we come from the cosmos? Or are we just one stop in a chain of creation that's been unfolding for billions of years? Whatever the truth, 3I/Atlas may soon provide the first tangible proof. If the collision happens, the story of 3I/Atlas won't end on Mars. The impact's sheer force would hurl fragments high above the planet's thin atmosphere, scattering debris into space. Some of those pieces, small, metallic, and carbon-rich, could break free from Martian gravity entirely, setting off on new trajectories across the inner solar system. Astronomers call them messenger stones, shards of alien matter carrying the chemical memory of two worlds colliding. Simulations at NASA's Jet Propulsion Laboratory show that a portion of these fragments could eventually cross Earth's orbit within a few years. Most would burn up harmlessly as meteors, streaking across the night sky in bright, short-lived trails. But a few might survive atmospheric entry, falling as meteorites that scientists could one day pick up, hold, and study. The first physical samples of interstellar material ever to touch human hands. To planetary scientists, that would be a discovery beyond price, tangible proof that we are not isolated in the cosmic chain of matter. But this possibility also carries a darker implication. If rocks can carry minerals across light years, could they also carry something else? Organic molecules, dormant microbes, or even precursors of life? The same process that might have seeded Earth billions of years ago could now be repeating in reverse, sending alien chemistry back our way. The Panspermia hypothesis, once purely theoretical, suddenly feels less like speculation and more like a slow-motion exchange between worlds. Across global research centers, preparations are already being discussed. If even one fragment of 3I/Atlas lands here, it could rewrite everything we know about the origins of life and the boundaries between planetary systems. For now, the thought lingers quietly among scientists. If interstellar debris can reach us, then maybe it's already been here before. Maybe Earth itself is built from the remnants of collisions like this, echoes of ancient impacts that once carried the seeds of life across the stars. And if those fragments truly return, gliding through our atmosphere like sparks from another universe, humanity will have to face a haunting question. When we look at them, will we still be studying the universe, or will it finally be studying us? What began as a breakthrough in astronomy has quickly turned into something else. A warning. The discovery of 3I/Atlas isn't just proof that interstellar visitors exist. It's a stark reminder that the universe doesn't wait for us to be ready. For the first time, scientists have watched an object from beyond our solar system change its trajectory under the influence of the sun, bending toward a planet as if pulled by something more than gravity. And that realization has shaken the foundations of planetary defense. If a single miscalculation or solar flare could alter the course of 3I/Atlas by even a few degrees, the target might not have been Mars at all. It could have been Earth. That possibility has turned what was once a purely scientific observation into a planetary-scale alert. At NASA's Planetary Defense Coordination Office, researchers have begun running impact simulations not just for known asteroids, but for potential interstellar impactors, a category that didn't even exist a decade ago. These models show how unpredictable such objects can be. Moving too fast to intercept, too dark to track for long, and carrying unknown materials that defy radar or optical detection. Thanks to the James Webb Space Telescope, humanity caught this one early. Webb's precision readings, combined with ground-based data from Chile and Hawaii, allowed scientists to identify the anomaly before it came too close to Mars or us. In response, major space agencies have formed a real-time data exchange network, something the world has never seen before. Every few hours, orbital data, chemical readings, and velocity projections are transmitted across continents, feeding into shared AI systems that predict the object's behavior. The effort has quietly become known as Project Atlas, named after the very visitor that inspired it. For now, the danger appears distant, but the lesson is clear. 3I/Atlas has proven that the cosmos is not a closed system. It's a moving, shifting sea where alien debris can appear without warning. And in that sea, Earth is a small, fragile island. The discovery has sparked debates far beyond the scientific community. Lawmakers are discussing new international protocols for interstellar object monitoring. Engineers are revisiting long-shelved concepts for nuclear deflection missions. Philosophers and theologians are asking what it means to live in a universe that is, at its core, unpredictable and alive. Some astronomers call this the cosmic awareness moment, the point when humanity finally understood how exposed it really is. For centuries, we've looked at the stars as distant lights, symbols of wonder and hope. Now they look back at us as reminders of scale and vulnerability. The James Webb Telescope has given us more than data. It's given us perspective. Every pixel of light it captures from 3I/Atlas tells the same story, that the universe is vast, restless, and indifferent. Yet within that indifference lies a challenge: to keep watching, to stay aware, and to remember that survival in space begins with paying attention. As 3I/Atlas draws closer with each passing day, the James Webb Space Telescope continues to watch, transmitting its final haunting images back to Earth. Each frame feels like a countdown, the faint shimmer of a traveler from another world inching toward its destiny. No one can say for certain whether it will skim past Mars or collide head-on, but one truth is already clear: this moment has changed how humanity sees the universe. For generations, we believed we were only observers, distant witnesses to cosmic events that unfolded far beyond our reach. But 3I/Atlas has shattered that illusion. It has shown us that we are part of the motion, caught in the same web of gravity, time, and chance as everything else drifting through the stars. Whether it ends in a blinding impact or a silent pass, this will stand as one of the defining moments of the 21st century. A reminder that space is not a backdrop, but a living stage where new chapters of existence are still being written. Somewhere on the edge of that red horizon, Mars waits. If contact comes, the night sky will erupt in light, a dawn unlike any other, painted not by the sun, but by the meeting of two worlds. And long after the dust settles, when future explorers gaze upon a scar on the Martian surface, they may wonder what message the universe was trying to send us. Perhaps it was never about destruction, but connection, a reminder that every spark of life, no matter how small, is bound within the same chain of cosmic fate. So what do you think? Will 3I/Atlas simply brush past Mars? Or are we about to witness the first true interplanetary collision in human history? Share your thoughts below. And don't forget to subscribe, because Mind Gap will be here when the Red Dawn begins.